So basically, in projectile motion, we have to make some assumptions first. Projectile motion is like a parabolic or a curve motion starting from one point, ending up at the same point. Let's suppose if we take example of a football. So if we kick a football from the ground and when it moves into the air and then lands on the ground, so that motion is called the projectile motion. And in the same way, just like if we launch a missile from the cannon, so definitely that is also making up a projectile motion. And when you throw any object with the help of the rubber band, so you stretch the rubber band and you release that rubber band, so it also moves like in a projectile motion. So these all examples are related to the projectile motion. The game of Angry Bird also gives you the motion related to the projectile motion. So we launch at a certain angle and it makes like a curve motion because of the weight of a body and ends up at the same level. But before explaining the whole projectile, we make some assumption. First of all, air resistance, again, negligible in our case of projectile also. So in projectile motion, so for example, if we mark x and y axis, so this is the representation of the projectile motion. And in this projectile motion, for example, when we, let's suppose if we kick a football from this point, so it always travel tangent to the curved line, just like the circular motion. So this is the direction of the velocity. But because of the weight of a body, the weight of the body or the gravitational force always tries to pull that body in downward direction. So because of that weight of body, the force of gravity acts on the object in downward direction everywhere. And one more idea in this projectile motion, we can make the components also. So one component of the velocity is the vertical component. This is the vertical component of the velocity, and this is the horizontal component of the velocity. So in the projectile motion, we also need to make the components of the velocities or the components of the vector given in the diagram. And if we divide this whole motion into the half, so half represents the moving upward motion and the other half represents downward motion, right? So before writing all the equations, first if we write down the assumption. So the first assumption that we discussed, air resistance is negligible. So air resistance is negligible. So there is no air resistance or there is no air or resistive force acting on the body with the help of the air resistance. So with this idea of air resistance, we can say the sum of all forces acting on the x-axis is equals to 0. Because normally in our daily life, for example, when we are running or when we are driving a car, so air resistance is always in the opposite direction. But when there is no air resistance, so it means there is no opposite force acting on our body. So it means all the force acting on x-axis will be equals to 0. So there is no resultant force acting on x-axis or on horizontal axis. In the same way, when there is no force on x-axis, so there will be no acceleration on x-axis, right? So horizontal force is 0, horizontal acceleration is 0 because there is no air resistance present in the environment. So horizontal component always remains the same for the velocity. Horizontal component of the velocity remains the same. And the second idea about the vertical forces. So if we talk about the vertical forces, so only the weight of the body is acting in downward direction because there is no air resistance. So when we drop any object from a certain height, so air resistance acts in the opposite direction. Just like the concept of terminal velocity we discussed for the parachutist. But right now, when there is no air resistance, so there is only one force acting on the body, which is the vertical force acting. That is the weight of the body, right? So one more point that we mentioned. So there is only one force X on the body in projectile. So there is resultant force which is equals to the weight of a body. Horizontal component remains the same. In vertical component, only weight of the body is acting. It is constant. So only the vertical component of the velocity changes because when body is moving in upward direction, so if we draw the components, so the components, if we mark for the body at this point, so vertical component is in upward direction, but when it is moving in downward direction, So these are the components, right? So vertical component is changing and it is also changing with respect to the direction. So the weight is the only resultant force and the direction of the velocity also changes because when it rises up, so direction is different. When it falls, so direction is different. So Vy changes. Okay. And from the right angle triangle idea, just like we make the components. So from this component, we already know about the horizontal and vertical component. For example, if we want to calculate the vertical component Vy, so Vy is equals to perpendicular upon hypotenuse, which is equals to sine theta. So with the help of sine theta, the perpendicular is Vy, hypotenuse is the vertical, resultant velocity direction which is moving. So finally, Vy is equals to V sine theta. In the same way, if we want to calculate the x component, cos theta, V cos theta. So in this way, we can make the components and we can calculate any unknown quantity related to x-axis and y-axis. And we already know about the equation of motion. So we can apply equation of motion with respect to the horizontal component, with respect to the vertical component, or whatever the component they are asking about. And in the same way, if we talk about the energy levels, like what will be the value of energy in projectile, resultant force, like it is the only weight acting on the body. So if weight is given, so we can use that value. But if they are not asking about the resultant force or the weight of the body, so in most of the question, it is like in kinematics. In kinematics, we not talk about like these resultant forces acting on a body. So we mostly like 95-99% we focus on equation of motion and the motion of a body, because this is the part of kinematics, right? In dynamics, we talk about forces. So in this motion, we have only one force already, that is the weight of the body, and that is already understood, which can be calculated with from the formula W equals to mg, right? For example, if you consider the question related to this projectile motion, so you will get this type of questions. Mostly questions are linked to the equation of motion. Only the idea of projectile used in the question. So this is one question we discussed last time related to vertical component. And let's suppose if we consider this question, yes, basically if they talk about the vertical component, so definitely in vertical component weight is acting, so we can multiply with sine theta if they ask to calculate the component, right? And if the value of mass is given, so let's suppose if the value of mass is given, so we just need to use W equals to mg to find out the unknown quantity of the weight, right? This is one question from the projectile motion idea. And in this question, water leaves the end of a hose pipe with a horizontal velocity of 6.6 meter per second as shown in figure 2.1. Point P is at height h above the ground and the water hits the ground at point Q. The horizontal distance from P to Q is 3.5 meter. Horizontal distance is given 3.5. We can observe in the diagram also. Air resistance is negligible. Assume that water between P and Q consists of non-interacting droplets of water and the only force acting on each droplet is its weight. So it is clearly written there is only one force, which is the weight of the body. Explain briefly why the horizontal component of the velocity of a droplet of water remains constant as it moves from P to Q. So for 1 mark, we need to explain why the horizontal component of the velocity of a droplet of water remains same. So any idea how to explain? No, there is only one force acting, which is only the weight of the body, and that's why we can say that a resultant force acting on a body, especially on x-axis, is equals to 0. So it remains same, right? So air resistance is not present. So resultant force on x-axis is equals to 0, and acceleration on axis is also equals to 0. And B part show that the time taken for a droplet of water to move from P to Q is 0.53 seconds. So we need to show that the time duration for a droplet of water to move from P to Q is 0.53 seconds. So we need to prove. So for 1 mark only. Okay. So in this question, we have horizontal component given already. Horizontal distance is given 3.5 meter, right? And initially the speed of the droplet is also given. Horizontal velocity is also given, which is 6.6 meter per second. So which equation of motion helps you to find out the value of the time taken? S equals to Vt, right? Because we know that horizontal component of velocity is given, the value of horizontal distance is given. So we can simply use S equals to Vt formula to find out the time taken. Speed is 6.6, distance 3.5. Okay, if you apply this equation, V square is equals to U square plus 2AS. So the problem in this equation is, we know that horizontal velocity always remains the same, right? So horizontal velocity always remains the same and acceleration is 0. And from that equation, time is not given. So how to calculate time from that equation? So that's why we have to use this equation, because time is only given. And for example, if you apply the formula in this form, right? So from this formula, we know that acceleration is zero. So this whole quantity becomes zero. So it means you will get the same result, S equals to Vt. S equals to Vt, or T is equals to S over V, right? The same formula, 6.6. Now it is correct. 3.5 divided by 6.6 equals to 0.53. So it is proved. And C part, calculate the height. So height means they are talking about vertical component. And in the previous part, we use horizontal component. So when horizontal component is given, or when we are working with a horizontal component, so we use only the values of horizontal components. And when the vertical component is given, so we use the value of vertical component only, not any other. So if we talk about the vertical component to calculate the height of the body, so we only know that in downward motion, because it is starting from the top. So in downward motion, if we consider vertical downward motion, initial velocity is zero and it is moving in downward direction. So the value of A is positive. Is 0.53 square. Multiply by 9.81 divided by 2. 1.37, or round off 1.4 meters. So this is the answer for the height given. D part, for the movement of a droplet of water from P to Q, state and explain whether the displacement of the droplet is less, more, or the same as the distance along its path. So we need to explain whether the displacement of the droplet is less than, more than, or equal to the distance along its path. So they are talking about displacement. So what do you think about displacement, that it will be same, different, or greater as compared to the distance from P to Q from this diagram? Okay, so it will be different. And we know that from P to Q, if we want to mark the displacement, So displacement can be marked in the form of a straight line from P to Q, like this, right? So this is the value for displacement. It is the shortest distance between two points in a straight line in a specific direction. So less than the distance. So displacement is the shortest distance. So between P to Q, displacement is the shortest distance and it is less than the distance. So it is less than the distance. And in part E of the question, calculate the magnitude of the displacement of a droplet of water that moves from P to Q. So to calculate the displacement of a droplet of water that moves from P to Q is very simple. Again, from the reference of the diagram, right angle triangle is given. Horizontal distance is 3.5 and vertical height we calculated equals to 1.4. So hypotenuse is unknown. So for right angle triangle, we can use the magnitude of displacement by using the hypotenuse Pythagoras theorem. So on hypotenuse, we have displacement given. So from this idea, we can calculate the displacement. Because vertical height is 1.4, horizontal distance is already given 3.6. 1.4 square plus 3.6 square equals to 3.86. Or round off, we can say 3.9. So this is the displacement from P to Q and distance must be greater than 3.9, right? Sorry, it is 3.5. 3.76. 3.8 answer. So this is one question. Okay, in this question we have um okay. So this is the same idea, horizontal distance displacement. So this question is also like the same. Okay, for example, if we consider this question, a small block is lifted vertically upward by a toy aircraft. Up, as the block is moving upwards, the string breaks at time t is equals to 0, and the block initially continues moving upwards and then falls and hits the ground at time t is equals to 0 0.9 second. The variation with time t of the velocity v of the block is shown in figure 2.2. So in figure 2.2, the velocity time graph is given. This is the velocity time graph given. So initially velocity is decreasing because it reaches the maximum height and then it starts to fall. So this graph represents the rise and this represents the fall. Because in question it is mentioned the block initially continues moving upward and then falls. So when string breaks, so it continues to move in upward direction and then it starts to fall. Okay. Now the question is, air resistance is negligible. State the feature of the graph in figure 2.2 that shows that block has a constant acceleration. So which feature of the graph shows that block has a constant acceleration? Okay. So this is a speed time graph, and from speed time graph we know that if we find out the gradient of the graph, so gradient of the graph represents the acceleration. So gradient. And the second part, use figure 2.2 to determine the height of the block above the ground when string breaks at time t is equals to 0. So we need to find out the height of the block above the ground when string breaks at time t is equals to 0. So when string breaks at time t is equals to 0, so we have two types of representation given in the question. The first one is this right angle triangle, and this is the second right angle triangle. So in the first right angle triangle, uh, the height is 1.96 and the base is 0.20. So the first distance is equals to the area under the curve 0.2 into 1.96 divided by 2. Point 196. And for the second right angle triangle, which is starting from 0.2, it is ending up 0.9. So the horizontal distance is 0.7, vertical is 6.86. 6.86. Basically, right now we are talking about distance, so we will consider that negative sign also after calculating this value, right? So multiply by zero point 0.7 divided by 2. So it is equals to 2.40. And now they are in opposite direction, just like you mentioned for the negative sign. So when we add them, so both are in opposite direction. So one is positive, other is negative. So it means, yes, we need to subtract them. Both are in opposite direction. So 2.2 meter is the distance or the height of the block above the ground when a string breaks at time t is equals to 0. Because in question it is mentioned a string breaks and it still moves upward and then fall. So that's why we also subtract over here because we need only the downward part, not the upward part, right? So that's why they automatically subtract over here. And the C part is the block has a weight of 0.86 Newton. Change in gravitational potential energy at time 0 and 0.9 seconds. Gravitational potential energy is equals to mgh. Mg is equals to W multiplied by H. So height is 2.2. 1.89. So we can also round it off to 2 joules or 1.9, right? And on figure 2.3, sketch a line to show the variation of the distance moved by the block with time t. From time is equals to 0 to time is equals to 0.2 seconds, numerical values of distances are not required. So numerical values are not required on figure 3.3. Sketch a line to show the variation of distance moved by the block. In our graphical representation, speed time graph is given. And we have now distance time graph given, right? So from this graphical representation, the speed time graph is given. And finally, we need to find out the distance, or we need to represent the graphical representation with respect to the distance and time graph. So how to represent the graphical representation? It will be like a straight line, curved line, horizontal line. Because in this question, initially we have a small distance and then we have large distance. So we need to make a line from the origin, because when it drops from time t is equals to 0, so distance covered from time t is equals to 0 to point 9 seconds, distance increases. And we need to show the gradient of the line which is decreasing. For example, like this. Because distance time represents speed. So this is a decreasing curve. Decreasing curve or decreasing velocity, right? So this will be the graphical representation because they are talking about time t is equals to 0.2 seconds. And at 0.2 seconds, basically it is not constant in the graph of the speed time graph. You can see this is 0.2. So at 0.2, you observe that speed decreases to 0. Initially, it starts from maximum, then it decreases to 0 at time 0.2 seconds. So that's why it must be a decreasing curve because its speed is decreasing. If its speed is constant, so then we can make a straight constant line that shows you distance is changing with equal rate of time, right? So that's why we used to draw a curved line. And the final part of the question, a block of greater mass is now released. So we increase the mass of the block from the same height and with same upward velocity. Air resistance is still negligible. State and explain the effect, if any, of the increased mass on the speed with which the block hits the ground. So any change in the speed of at which it hits the ground if mass is increased for the body. So basically, if we increase the mass and since there is no air resistance, so let's suppose in the space, if we drop heavy object and if we drop a light object, so all objects falls at constant rate because there is no air resistance. So air resistance will not affect the motion of any body and all objects falls with the same rate. So in the same way, in this question, if we increase the mass of the body, so the speed of the body is independent of mass. So there will be no change on the speed of the mass of the body at which it hits the ground. So the final answer, air resistance is negligible and acceleration of free fall is not dependent on mass. So it means no effect on the speed. right? So this is the final answer. So this is another question from the kinematics idea, right?